Students, please note down this question after the theory which we have covered in the previous lecture. Let's quickly attend this problem. Now, this is the circuit, and at time t is equal to 0, this is closed, 10 volts, this is a resistor, 3 ohm, this is 6 ohm, then this is the inductor which is 2 Henry. Currents flowing are, I1, I2 in this direction, and one resistor is here at 2 ohms. Now, let's quickly talk about at t is equal to 0. At t is equal to 0. Okay. Now, at t is equal to 0, no current flows in the branch inductor. It behaves as a open circuit. So, inductor, we can write inductor, no current, and it's an open circuit. Open circuit. Okay. So if I have to redraw it, then everything remains the same except this is not, it is open, right? This is open. So let me quickly draw it. This is open. So this is 10 volts, 3 ohm, 6 ohm, I1, I2, I1, I2, 2 omega. Now, the total, if you see the resistance, because this is open, so this mesh is useless. You can just remove it off. So, effective resistance is 5 and delta V is equal to 10 volts. So, I can say I is equal to delta V by RE, which is 2 ampere. Okay. Now let's take another situation when it is a steady state. So when it is a steady state, this circle, this inductor would be closed. It would be as good as a as no inductor, no wire, no connection broken there. It's direct connection, so it would not cause any hindrance. It's a direct connectivity. Or if I have to draw it, then it becomes so this becomes what? This is 6 ohm and this is 3 ohms, correct? And this is 2 ohm as it is. This is 10 volts. Now if I break it further, so the current which will flow is 2.5 ampere by simple calculation, so I'm not getting too much into it, and the total voltage here would be 5 volts, and again here it would be 5 volts because both are in parallel. Okay. Or now I can say effective resistance is equal to R1 R2 R1 plus R2, or I can say 6 into 3 or 6 plus 3, which is equal to 2. Now I is equal to 10 by 4, which is 2.5 ampere. Okay, and delta V I can say there as IR, which is 5 volts. Okay, so this is in the steady state. Now in this case also I can say that if I calculate, let me put it, use another color here. So I1 would be equal to 5 by 3 amperes, which is 1.66 amperes, and I2 would be what? 5 by 6, which is equal to 0.33 ampere. Okay. So students, let's now spend some time understanding decay. Now you look at this circuit first and then I'll come to this. In this circuit, imagine there is a current flowing around and all of a sudden, I open this S1 switch. What will happen? This battery will get disconnected. Which battery? This battery. Now, because the battery is getting disconnected, so ideally there should be no current anywhere. Now, but actually it will not happen so. Why? Because there is an inductor here. This inductor, as you know, will not let what is happening, as simple as that. Like if current is dying, it will not let it die. If current is increasing, it will not increase. So in this case, current will die because the battery is being removed. So this inductor will not let the current die. Now, so what will happen? Because the current is dying, it will keep the current in the same direction for some time. So initially the current was this, positive to negative. So I will now not talk about this, I will just talk about this. In this, the current will still remains in the same direction. Why? Because the current was dying and this inductor will hold it, will create an induced current, and it will keep it as such, the direction of which would be as this battery in the same direction. So this will be positive, this would be negative. Now, and this is the resistor. As you see, I am not talking about this because this has been already checked off because this switch is open. Okay, so I will start from here. Now, as current reaches its max value, what happened? Let's say I naught is the max value. So I naught is nothing but E by R. Now we open S1 and close S2. Close S2. I'm sorry, I didn't say that. Yeah, you are correct. So we have closed this S2 because if we check it off, the circuit would be completed only when S2 is. So that is also to be done. What to be done? This needs to be open, this needs to be closed. Now we close S2. Now then battery removed. Okay, now what will happen? As I said, so now what is the EMF of the current here? The EMF of the current is L di by dt. But remember, it is in the same direction. It is in the same direction. So it will be minus as per Kirchhoff's law. Correct? So minus LDI minus IR will be equal to 0 as per Kirchhoff's law, right? Now Kirchhoff's law says if the direction of the current is from negative to positive, it will be minus. Correct? Very good. Now, or I can say minus IR is equal to L di by dt. Now let's segregate it, take dt here, and then I can put it minus R by L dt is equal to di by I. Now when current was 0, to current is I naught. Correct? Now 0 to t in the time t and I naught to I. Correct? So now we will integrate it. Correct? Now let me also write this just to for so that you remember this. Current do not die instantly because of inductor. Correct? Now yeah, that's it. Further, after integration we will see what minus r by L t is equal to log E, okay, mod of I, as you know, I'm integrating it, right, from I to I naught. What will happen? It will become minus RT by L is equal to log EI minus log I naught. Okay. Further, I can say RT by L is equal to log of E I by I naught, right? Or I can say I by I naught is equal to E minus R by L, correct, into T. Further, if I simplify as I is equal to I naught E minus T by tau, what we have studied earlier. So this is the final formula. Okay. Now again, if we take a moment and define tau. So to define tau, let me write it here. If I have to define tau, tau is nothing but L by R. So I can say at T is equal to T, if I substituted in this, I is equal to I naught E minus 1, correct, which is nothing but I is equal to 0.37 I naught. So it is basically the current is 0.37 of the maximum current. If I have to draw the graph, also I can write it, I can draw it in this fashion. I can say it is, if this is the decay, then this is I naught, and this is 0.37 of I naught, and this is tau. Okay, and just to say this is time. Okay, I hope it is. Just pause the screen and proceed from there.